Hi, my name is Vahan Davudyan. I'm a physics experimentalist for 30 years. In these last 30 years, I have replicated most experiments done with the famous scientists. Well, of course, some of them I couldn't, I didn't have the tools, or I couldn't buy the material, or it was beyond my expertise, but overall, I've done 80% of those experiments. And in fact, these are unique experiments I have never seen in any physics books. And I have uploaded like 17 theories like 3 months ago on YouTube. It was great success. So first of all, I just wanted to thank YouTube for providing this fantastic opportunity for us so we can upload our videos free and then people can watch it and then we can even find someone interested in something, we can exchange views. And in my opinion, YouTube is providing so comprehensive job that is beyond my imagination. YouTube is like a huge university. It's connecting everyone together. As a matter of fact, I call YouTube synapse. Synapse is a junction in a human's brain which is connecting billions of neurons together, and then all the communication and everything else is done with those charges and everything else goes through those neurons. And that is exactly what the YouTube does. And then how do I know who I am? How do they know what is my expertise? How do they know I'm a physics experimentalist? The only way is we have to upload them on YouTube and then people can watch. If they love it, they can watch all the way. If they don't, if it's not their interest, they watch something else. But overall, YouTube is providing this fantastic job. And honestly, I think since the YouTube started in 2005, they changed the world and they promote the science, they promote people understanding. As a matter of fact, I watch YouTube like 3 hours, 4 hours a day. I could never even watch TV, the best movies 4 hours a day. Well, of course, I do watch National Geographic and the universe. Those days showing universe, I watch like 5 hours. But overall, YouTube is providing this good service because you have a choice to what to choose. And then the good thing is they're promoting science. Now, today, we have a special thing. So far, as I said, I have 5 theories already today, and I did all of them. This is the last one, and they were about insects and animals. Because these last 30 years, my great inspiration came from nature, animals, insects, and plants. And this last one is about the plants. It's called helicopter because it is amazing seed, and then I will explain exactly how that works. And it is called Samaras, or it's a maple tree seed, but it's amazing. I call them helicopter also because when they fall, they just rotate so good. Okay, let me take this off and then I will explain exactly what I mean by this theory. Okay. So this is the one. This is going to be our topic for today. Well, of course, this is enlarged a lot because the actual side is 2.3 centimeter, and this is almost like 5 or 6 inches. So this is the theory for today: aerodynamics of seeded fruits, Samaras, compared with helicopters by Vahan Davudyan, physics experimentalist, and my email is vahandavudyan@airfoil.com. And in fact, there are hundreds of them. This is called wind dispersal of seeds. First of all, I have to explain a little bit about the helicopter. Well, of course, this is amazing. The wing can be compared to windmill, can be compared to airplane, but I realize it's better if I compare it with a helicopter. The reason why helicopter is closer, and then I had to make my own blade. I show you, see? It's amazing, the birds helicopter, windmills, airplanes, and everything, they have this in common. It's called airfoil. So when it rotates like that, see, it's creating low pressure and high pressure, and it's causing a lift. And it's amazing how the nature does this. The reason why they're helicopter, because they don't fall exactly where the tree is. They fall a little bit further, and how the nature did, I don't know, it's beyond my comprehension. How the nature does, and when they go a little bit further, then that's why they survive. We have more and more trees. And in fact, helicopters and the airplanes are the same. Well, of course, this doesn't show a lot, this airplane. They're all airfoil. They're all airfoil. So the wind is going here much faster than the slower here. So what happened is causing a lift like that. I have a better one, I show you. See, this is a bigger one. Well, of course, there is no fuselage here. You see how curved that is? Earth is going, Earth is going much faster here and the slower here, and the difference of pressure is causing lift. Aerodynamics of seeded fruits, Samaras, compared with helicopters by Vahan Davoudian, physics experimentalist. Physics of helicopter blades. A helicopter is a type of rotor craft in which lift and the thrust are supplied by horizontally spinning rotors. This allows us the helicopter to take off and land vertically, to hover, fly forward, backward, and laterally. This attribution allows helicopter to be used in congested or isolated areas where fixed-wing aircraft cannot perform. Basics of the lift is Bernoulli's principle, Newton's third law. The rotor blades of a helicopter are rotating wings that create a lift. It is governed by the blade shape, which, as I said, is called airfoil, creating lower pressure above each of the blade, causing it to rise and rotates the pilot harder. The pitch angle, then, well, of course, like airplane, they can descend, ascend, and so and so. Anyway, wind dispersal, and that's amazing how this wind dispersal works. So besides conducting physics experiment, my great inspiration came from nature, animals, insects, and plants. Some dispersal seeds resemble parachute like this, some helicopter like this, and dispersal maple family trees, and it's called, the actual name is Samaras, or helicopter they call it, olive family ash helicopter, also called whirlbird. See, yeah, I have it over here. Maple family, Samaras, with aerodynamic wings. The wings typically have a slight pitch. I show you, I have one over here, a slight pitch. And then the amazing thing is, I have never seen in any book that they explain this. Let me get this seat. You can see, I have never seen in any book, they did not explain what happened to the laws of inertia. Well, of course, unfortunately, I brought this from Denver, and then we had to move 3 times, and then I lost all of them. So this is the one, see, this is amazing. And then if you let it go, it's dried a little bit, but see, it's going to rotate. Look. Did you see? Let me try one more time. Okay, so the reason why it was not explained, because, I've done a lot of experiments in physics, I found out exactly what the answer was. See, the wing itself, it is not airfoil, but it's amazing. It's exactly like fine fibers, and in fact it's enforced. You see those lines over there? It's enforced a little bit, or maybe few millimeters, I would say, yeah. And then wing weighs less than milligrams. Can you believe how the nature? But the important part is, seed as is a little bit heavier. So what happened when this rotate, this part, the seat is resisting acceleration. You see, this is unique engineering by God. So this is resisting acceleration, and because it's so massive, and that part is so light, it's going around. And then I have seen sometimes when it's windy, they land maybe like 100 meters away. So that's the way they survive. But of course, they were like hundreds of them. I had to choose some of them. And like one of them is called whirling knot. And you see, they have one thing in common. See, that is the seed, or legume sometimes they call it. This is the seed, this is the seed, and then these are the seeds, and these are the seeds. They have one thing in common. They are resisting acceleration. And in fact, these two wings, or two leaves, acting exactly like a helicopter. But normally, I've seen in Denver, we had a lot like this. When it falls, they fall two together, and I don't know why. But I tried two, and then I realized they don't rotate that good. But one is rotating much better. And then like this one is amazing. It's 100% radial or symmetrical. And how could, nature do something like this? And see, each one is called parachute. But if you pay attention, here's something important. Parachute itself has a seat, and this is one of the greatest laws of physics. It's exactly like, I'm hanging like this. Well, I would call this umbrella. If you call your umbrella, and your umbrella has a little weight on the bottom, it's going to go like this. So it's not going to change the orientation. This is exactly what this does. This is called dandelion clock, and then each one, probably, I have no idea how many there are, but when wind blows, hundreds of these go in air. Well, I had to enlarge this a little bit. You can see parachute seat, but this is the thing. It was never been explained, so I'm not explaining what happened. This is long, and this is like a helicopter blade, and then in fact this is like an upside down helicopter, and imagine that mass is keeping the orientation. But when they fall, both of them are rotating, and then I noticed something amazing. They are not rotating if it's one. So like this one is called glider. You can see where the mass is. Mass is in the center, but because of the big surface area, this also go away. But in fact, there is a big physics involved on this. It's called the conservation of angular momentum. And how could you expect? Nature does something so amazing, and then they fall, they fall far away. And then I had to explain a little bit. Laws of inertia and aerodynamics work together. So this was never ever explained, inertia, because that is the first law of motion. Things are resisting acceleration. And how did God or whoever created this knew that the seed or legume is supposed to be off-center so it can resist acceleration and it acts like a helicopter? That is just fabulous anyway. So since orientation, then like I said, is the combination of aerodynamic and an inertia that cause this to rotate and go further. They won't tumble or rotate up and down, just down toward the center of the earth. Some seats resemble parachute, glider, or helicopters. Imagine seats without the wing would fall exactly under the tree. And imagine, like apple falls, right? Imagine if the apple is, birds took most of it, is all is left is a seed. So what will happen? That apple is going to fall exactly where the trunk is. But this one is unbelievable. Imagine always it falls, even if there's no wind. I remember I took notes in Denver. and then always they fall 6, 7, 8 meters away, and sometimes when it's windy, they go a lot. And then when I studied what the forest and then the forestation and things like that, I realized some of them were carried away like 100 kilometers. I mean, it's beyond my imagination. How could they do that? I mean, how could they travel so far? So it just happened. So that is the way it is. And now I'm hoping that, you guys learn a lot about this, helicopter. And next time you see, you can explain it to your kids or to, young generation. What is the laws of physics beyond this? So it's laws of aerodynamics and laws of inertia. Well, of course, I uploaded my videos on YouTube, and then I'm so happy I did it because it's a great success. In 2-3 months, more than 4,000 people watched, and then I had 17 theories, and this is going to be 18 of them, and most of them were so comprehensive, and in fact, I have never seen in any books, in physics books whatsoever, that these are unique. I'm not implying or suggesting I'm an intelligent person, but like I said, these are so unique, this experiment, and I've never seen anyone conducted this kind of experiment. There's some university professors, because I'm retired now, don't work. I used to work in international companies so many years and then doing laws of physics, but now I'm retired. All I do is just upload everything on YouTube. Well, of course I have more theories, but I have to combine them together, put it on YouTube. And in fact, some people call me, some people email me, they love the ideas, and as a matter of fact, some of them were physicists, they loved it. So anyway, there's some physicists that I like to mention. One of them is a fantastic professor. His name is Dr. Michio Kakou, and then he had so many books. I read his books. He's been, God knows, so many years. He's explaining the universe and the other places, programs. One book he has is called Teleportation. I love it. And the way I see it, he's so smart, he can see 100 years ahead. Well, his prediction is, in another 10 or 20 years we will have teleportation. I think so. Everything is possible, because when Jules Verne said 100 years ago we will go to planet, people have no idea what he was talking about, but it happened. When Albert Einstein died in 1955, we were not even in space. But what happened? His prediction came true. General relativity, special relativity. Well, beside Michio Kakou, there is a young girl. Her name is a physics girl, and Dr. Diana Cowan. She's so good. Her knowledge is beyond my comprehension. It's so good, and then I love it. And in fact, every night I have to watch Miss Cowan. Every night, because she's so good. There's another professor. His name is Dr. Nick Lucid. He's got great sense of humor, and then he calls everything crazy, and I think whoever knows the science, they are crazy anyway. So, and then his explanation is always good. There's another one called Dr. Derek Miller. He is good, and in fact he has experiment like me, unique experiment. He's also good. And there's another professor, his name is Dr. Arvin Ash. He's also good. And then there's another person, they call him Professor, and in fact his name is Dave, Professor Dave. And then, I'd like to meet them if I can. I'd like to get in touch with them. I'd like to exchange views. I think this is the way we can promote science. And like I said, like YouTube was like a synapse. If that synapse is not connecting, brain to everywhere, you won't be able to have short memory, long memory, you won't be able to remember the past, you won't be able to analyze things. So, and I think that's amazing, and I'm hoping one of these days, this scientist will get in touch with me, and I also have a big list of the universe, and then I won't be able to tell because of the time. There are more than 20, 25 astronomers. They are so good. The way they explain, I understand 100%. Well, of course, the good thing is they never use formulas and things like that, they always have the comparison. Because I remember Niels Bohr was one of the greatest minds in the history of science. He said once, if you want to learn science or physics, you have to scale down or you have to scale up. So he compared the electrons with the solar system. When I was so young, I don't know. I remember that all the time because see, that comparison makes so good. That is the way you can visualize in your mind. That is the way you're conceptualizing in my mind. And then Ernst Rutherford did the same thing, but his was not as good as Niels Bohr. And I will never forget, whenever I'm talking about Mars, Jupiter, and then I remember Niels Bohr. And this was my idea that, you know, if something works, in atomic and subatomic level can work in planetary level. And I think I proved it in my theories, and like I said, most of my theories are substantiated by experiment, except the one which is for the Kepler, and unfortunately I couldn't do anything because it's astronomical, but you know, university professor loved it because I cut the it half, and then I make two pendulum, and then I was explaining in university in Denver. They loved that, and then I realized the pendulum is exactly like a Kepler's second law. You know, a small swing and a big swing, and then I compare it to equal areas, equal time, and they loved it. Well, in fact, Kepler was amazing. Scientists, Copernicus, Kepler, Galileo, Albert Einstein, they proved that everything was good, and that was the only one I had the astronomical, but the rest, most of them were electromagnetism. If you watch my theories, charged particles and gravity and the Earth's electric field, it's already uploaded, and like I said, you can go, I even have a website, vahandavudyan@AOL.com. It's called GoDaddy. If you go there, you can see my theories, and I'm glad that it worked out fine, and I look forward to hear about you guys because when I was in electronic in LA a long time ago, 44 years ago, I learned something amazing. Oscillation will not sustain if there is no feedback. Well, in electronic, they call it tank circuit, and that's amazing circuit. And if it's harmonic oscillator, like a mechanical, they call it pendulum. The pendulum is not going to go forever because the second laws of thermodynamics comes in equation. It stops it because of the air friction and the friction of the pivot and some other things. But you know what? In electronic is the same way. Even in subatomic particles is the same way. And then we had a project, we had to make the transistor, put it on the inductor and the capacitor. So that is the fastest switch in the world. Can switch back and forth, back and forth, back and forth. And then we realized we were wrong because even transistor will consume energy. So finally they're not going to go forever. So that's the reason why second law is prohibiting everything. There is no perpetual motion whatsoever. And the second law is always come in equation, always you need to bring more energy, you need to supply more energy, and like I said, the oscillation will not sustain, you need feedback. If there is no feedback, the oscillation will stop. Thanks a lot for watching, and I look forward to hear about you guys, and anytime you need any question, I'll be happy to help because I'm retired, and then I have great passion for science. I can help anyone, even if it's beyond my expertise, don't worry about that. I can Google it, I'm a great researcher. All these libraries, they know me because I go there hours and hours. I just go through the books and then find the best subject. So anytime you have any question, do not hesitate to just ask me. So I'll be happy to help you guys. Thanks a lot, and thank you for watching.